The last type of linear approximation problem that we'll see is a little bit less structured. It's more on you to come up with some of the important information. Here I'd like to use linear approximation to estimate the quantity square root of 146, but to choose a value of a to produce a small error. So notice I only have the quantity I'm trying to estimate. I know at the end of this problem I'd like to be able to say square root of 146 is approximately equal to blah, but I don't have anything else. I don't have a function, and I don't have an x value or an a value. Let's start with the function first. So the function is going to be the easier part to start with. For that, I'm going to look at the quantity I'm trying to estimate. Here, square root of 146. This one, you want to keep your function simple, because remember, I'm going to want to take the derivative of this. So here, square root of 146, that kind of looks like square root of x. And this is a nice choice here, because I can take, if I were to take, say, 146 and plug that in for x, I would get back square root of 146, and that's what I'm trying to estimate here. So a lot of times we can pull this trick of pulling out the number that's causing a problem and just look at the function. So here I'm just working with the square root function. Just pull out that 146. Let's replace that with a variable. So here's my function, f of x equals square root of x. I still need an x value or an a value. And so what we're looking for is something that is close to 146, that we kind of, in air quotes, plays nice with the square root function, something that we know how to take the square root of. Because if we can do that, it'll make our calculations a whole lot easier. So I want you to you can pause for a second and think about it here for a second. But spoiler alert, the number I'm going to pick is 144. Well, first of all, I think it's kind of easy to see, okay, 144, that's pretty close to 146. But I know that square root of 144 is equal to 12. This is kind of why I chose this number. So square root of 144, that's going to be 12. And actually, this is my y value here. So if I think about this in terms of writing the equation of the tangent line, I've chosen my x value. I've found my y value by taking 144 and plugging it into f of x. All that remains is the slope of the tangent line. So remember that square root of x, we can also think about that as x to the 1/2 power. So let's see, f prime of x, this is 1/2 x raised to the negative 1/2 power, or 1 over 2x to the 1/2. If I want, I can write that as 1 over 2 square root of x, if that's a little bit easier to work with. I'm going to take my x value, or my a value of 144, and now plug that into my derivative. So f prime of 144 is equal to 1 over 2 radical 144. This is 1 over 2 times 12, which is 1 over 24. This is my slope. So okay, I have my x value, I have my y value, I now have my slope. Let's write the equation of the tangent line. Y minus my y coordinate is 12 equals m. This is 1 over 24 times x minus my x coordinate, which is 144. Here I should have y minus 12 equals 1 over 24 times x. Here I should have 6, but let me double check. 144 divided by 24, yes, minus 6. Adding 12 over, I have y equals 1 over 24x plus 6. This is my linear approximation L of x. So here's my linear approximation. The last thing I need to do now is actually use it. So I need to say, okay, well, square root of 146, remember that's what we were trying to estimate, that's going to be approximately equal to L of x. So that's L of 146. So this is 1 over 24 times 146 plus 6. So let's see if this works out nicely. It probably won't. Here I'll end up with 73 over 12 plus 6. That's going to give me 145. Oops, plus 6. Plus 6. This gives me 145 over 12, which as a decimal, this is approximately equal to 12.083 repeating. And so I can now say, well, this value, this is my L of 146. This is approximately equal to the square root of 146. That's my answer. So these problems are a little bit trickier because you are going to have to come up with not only a function, but a point that is close to the x value that you're working with, or close to the quantity that you're trying to estimate, that will work nicely with the function that you do decide on. Oops.